Hello, I welcome you all to this another interesting screencast. The problems read a horse on the merry-go-round moves according to the equations r equal to 8 feet, theta equal to 0.6 t rads, and z equal to 1.5 sine theta feet, where t is in seconds. Determine the cylindrical components of the velocity and acceleration of the horse when t is equal to 4 seconds. The second problem reads, a horse on the merry-go-round moves according to the equations r equal to 8 feet, theta dot equal to 2 rads per second, and z equal to 1.5 sine theta feet, where t is in seconds. Determine the maximum and minimum magnitudes of the velocity and acceleration of the horse during the motion. Both these problems are coming from the Engineering Mechanics Dynamics 14th edition by R.C. Hibbeler. Let's start with case 1, which is 12-179. Okay, so what do we have? This particular problem, let's write down. We have R equal to 8 feet, and therefore R dot is just going to be equal to 0, and R double dot is also going to be equal to 0. We have theta equal to 0.6 t, therefore theta dot, these dots just simply means these are derivatives with respect to time, right? Theta dot is just going to be equal to 0.6, and theta double dot is equal to 0. Then we have z. Okay, z is 1.5 sine theta, therefore theta dot is equal to 1.5 theta dot cos theta, and then we have z double dot, this is equal to 1.5, we factor out, then we're using a product rule, we have theta double dot cos theta, and then minus theta squared sine theta. Right, so we have done everything. We just need to plug in the equations. We have been asked to find the cylindrical components of velocity and acceleration when t is equal to 4 seconds. All right, so at t equal to 4 seconds, what do we have? Let's write down theta. Theta is just going to be equal to theta at t equal to 4 seconds. This is equal to this equation here. That's 4.6 by 4. That's 2.4. 2.4. This is rads. Right? We can work with rads if you want to. Myself, I prefer working in degrees. So I'll convert this to degrees. So rad and rads, they are cancels. And then we'll have a 2.4 by 180 divided by radian. So this just becomes a 137.51 degrees. All right. What else? That's about it, right? That's about it for now. Let's now find, we start with V R. VR is just equal to R dot, and this is just equal to R dot is equal to 0, so this is 0, feet per second. And then we have v theta. V theta is equal to r theta dot. This is equal to r is 8, theta dot is 0.6. So this we get 4.8 feet per second. And then we have Vz, which is as z dot. Z dot, it is here. So it's 1.5 times theta dot, which is 0.6, and then cos 137.51. Alright, so this we get a minus 0.6637 feet per second. Alright, so we are done with the first case. Then let's find the acceleration. AR is just going to be equal to r double dot minus r theta dot squared. This is just equal to this one. We know that this part here is 0. Alright, so this just gives us a minus, right? A minus r is 8 theta dot squared, that is 0.6 squared, 0.6 squared. So this we get a 2.88 feet per second square. And then we have a theta. This is equal to r theta double dot plus 2r dot theta dot. This is equal to theta double dot. This is 0, this part. So this just becomes, then r dot, this is also 0. R dot is 0, right? This is 0. Therefore, this is just going to be equal to 0 feet per second square. Then AZ, this is equal to Z double dot, and this is equal to, so we are using this equation there, right? That we know that this part here is 0 because theta double dot is 0. So we have minus 0.6 squared sine 137.51 times 1.5. Okay, so this we get a minus 0.3647 feet per second squared. Alright, let me check it again. Z double dot, that is 1.5 by 0.6 squared. 0.6 squared, then sine 137.51. Okay, so it's 30. Okay, it's not like this. Sorry. Let me check it again. 1.5 by 0.6 squared and sine 137.51. It's okay, right? Sine 137.51 by 1.5. Okay, I think it is fine. This is fine. This is fine. So it's 0.373647. All right. I think we are done for the first case. We'll solve the other one in the next video. Let's just outline. So we have all the values here. So these are the values for all the solutions. So we have VR, V theta, VZ, AR, A theta, and AZ. So I hope this particular video was helpful. We are going to solve the next problem in the next video. I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.